Hello students, I am Dr. Ritapa Bhattacharjee, Assistant Professor, Physics Department, Basic Science and Humanities, Swami Vivekananda Institute of Science and Technology. Today we will be learning some questions from Heisenberg's uncertainty principle in quantum mechanics. So the first question I have taken, it's a 2 marks question, came in MAKAUT 18-19 odd semester. So they just asked what is Heisenberg's uncertainty principle. So the answer is Heisenberg's uncertainty principle states that product of uncertainty in the position and momentum of a particle is greater than or equal to h cross by 2. Means if delta x is the uncertainty in the position of a particle moving in x direction and delta px is the uncertainty in the momentum of a particle moving in the x direction, then del x del px should be greater than or equal to h cross by 2, where h cross is h by 2 pi and h is Planck's constant. So this is a question of 2 marks. After that we will see another 1 mark question which came in 18-19 MAKAUT. It's a 1 mark question, odd semester of MAKAUT it came. Question is, it's a multiple choice and they asked Heisenberg's uncertainty relation is option A, del x del t greater than equal to h cross by 2, B, del x del px greater than equal to h cross by 2, C, del x del px less than equal to h, D, del x del px equal to 1. So the correct answer is, already you have seen, del x del px greater than equal to h cross by 2. That is B option is the correct answer. Next we will see a numerical problem which came in the year of MAKAUT 23-24 odd semester. Marks is 5. Question is, compute the smallest possible uncertainty in the position of an electron moving with speed 3,000,000,000 means after 3 7 zeros are there, meters per second. I have written another question which came in MAKAUT 18-19, also MAKAUT 2009, the same question with a little bit of language change. Look at here, compute the smallest possible uncertainty in the position of an electron moving with velocity 3 into 10 to the power 7 meter per second. Look at here, it is 3 into 10 to the power 7 meter per second, and here they have written after 3 7 zeros. Only this is the thing. And here they said that electron, and they assumed you know the mass of the electron. Here they have supplied you the rest mass, means non-relativistic mass of the electron is 9.1 into 10 to the power minus 31 kilogram. So how to solve this equation? We will be looking here. Already you have seen Heisenberg uncertainty principle is del x del p greater than equal to h cross by 2. So if that is the case, from Heisenberg's uncertainty principle we can write del x equal to h cross by 2 divided by del px, where del px is the uncertainty in the momentum of the particle. I have taken it in the denominator from this side, and h cross equal to h by 2 pi. Value 6.3 into 10 to the power minus 34 joule second, and after calculation the total value comes 1.054 into 10 to the power minus 34 joule per second. So that is the value. Now del Px is the maximum uncertainty in the momentum. From Heisenberg's uncertainty principle, we know the product of the position's uncertainty and momentum's uncertainty is greater than or equal to h cross by 2. Now, if the uncertainty is maximum, we can write del x del Px equal to h cross by 2. So, using this relation, we can write del x equal to h cross by 2 into del Px, where h cross is equal to h by 2 pi and the value is 1.054 into 10 to the power minus 34 joule second. Now, del Px is the maximum uncertainty in momentum. Okay, now using the concept of relativistic momentum, we can write P, that is momentum, is equal to mass into velocity, where m is the relativistic mass and the value is m0 divided by 1 minus v square by c square into p, where m0 is the mass of the electron, non-relativistic mass. Now this m0 value is already given to us and already known to us. So the value of electron's mass is 9.1 into 10 to the power minus 31 kg. So we are writing the value of mass here and we are taking the velocity which is given in the question, that is 3 into 10 to the power 7 divided by 1 minus v square by c square. So I have written the value of v whole thing square divided by value of c, that is velocity of light whole thing square. So that is 3 into 10 to the power 8 whole square. So if I calculate this whole thing, I will be getting the value of the relativistic momentum is 27.4 into 10 to the power minus 24 kg meter per second. Now what I will do is, I will calculate the uncertainty in the position. So uncertainty in the position will be del x equal to h cross by del Px max is equal to this value, the value of the h cross what we have obtained earlier, divided by 27.4 into 10 to the minus 24 into 2. So the answer will be 0.019 Armstrong. Thank you.